Introduction. This project addresses the limitations of existing libraries for precise attitude tracking in twin rotor systems. By leveraging the robustness and versatility of PX4 libraries, we have implemented a Kalman filter. This filter reduces noise and ensures smooth, accurate attitude tracking of a reference device. Our work aims to advance the twin rotor industry through cutting-edge technology and expertise. Objectives: access sensor data and actuators through the existing libraries to understand and interact with the hardware. Access the sensors and actuators using PX4 libraries to enhance system integration and functionality. Stabilize and implement the twin rotor system for precise control and orientation. If time allows, implement attitude tracking of a reference device, e.g., a smartphone, via Wi-Fi to expand the system's capabilities. Methodology: accessing the twin rotor with existing libraries. Install Navio OS to Raspberry Pi. Successfully complied PX4 firmware in Raspberry Pi. Modified the firmware as it is compatible with the locally manufactured sensor board. Got sensor data to the PC through MAV SDK library. Verified data received by manually changing the orientation of the sensor shield. Visualized orientation of the sensor shield. Results: develop PX4 firmware for the locally manufactured sensor board. Verified the data received from the sensor board through the PX4 firmware by changing the orientation of the sensor board. The attitude was estimated using the Kalman filters of the PX4 firmware. Gain hands-on experience in controlling the PX4 firmware. Problems. The Raspberry Pi's OS chip, which had PX4 firmware installed, was damaged. The sensor board of the twin rotor is different from our locally manufactured sensor board with PX4 implementation. When installing PX4 firmware onto the locally manufactured sensor board, it was not compatible. Therefore, the firmware needed to be adjusted to suit our sensor board. During the installation of the firmware, the IMU on the locally manufactured sensor board was damaged. Conclusion: we have modified the PX4 open source library to be compatible with our locally manufactured sensor board, completing the foundational and complex tasks. This modification enables seamless integration with PX4, allowing anyone to carry out a project with the sensor board while leveraging the cutting-edge technologies of PX4, thus providing advanced capabilities that would otherwise require significant time and expertise. The Kalman filter in PX4 allows for the optimal fusion of sensor data, reducing noise and enhancing overall system performance. By using the Kalman filter instead of the developed PID controller, the accuracy of the attitude estimation improved.